Our next speaker is Carol Reiley, and she's going to be talking about robotics.
All right, hi, I'm Carol. I'm always super excited to speak at Maker Faire. It's one of the most exciting and energetic crowds that there are. I'm a computer scientist and a roboticist, but a maker at heart. And I really, really love robotics, and that's one thing you should know about me. I've spent the last 15 years working on various applications of robotics. And the future I've always imagined has been one where robots play an increasing role in our lives, whether it be through entertainment or through space and underwater robotics to help us reach places that humans typically can't go, or if it's to help save lives through surgery or through disaster relief. I'm here really to focus on the human side of robotics. I've worked on designing robots really for humans, and it's really taught me how to have empathy, and I wanted to share with you today about how the thought process of how to use design for people and how do you really help people, which is the #1 reason why I chose to go into the field of robots. My specialty is in the area of teleoperation, and I work on these interactive technologies where a human and a robot work together to solve a problem. So teleoperation means that the human is controlling a robotic manipulator, which could be somewhere on the other side of the room, or across the world, or maybe even outer space. And the human is in full control. And it can be used in a wide range of applications where it might be either too dangerous or too time-consuming for a human to go. And robots really allow us to reach places that we can't go. And that's really exciting to me, where you can either use it to have kind of superhuman abilities, you can scale up your motions to have superhuman strength and pick up a boulder, or you can scale down your motions to have increased accuracy and precision. So when I was preparing for this talk, I started thinking back to my own childhood and why I got interested in robotics. And I had grown up in the 80s and 90s, which was a really interesting time. It was the age of the personal personal computer revolution. So I grew up with stories of people like Bill Gates and Steve Jobs who were creating these digital worlds through the computer. And as a child with the internet becoming popular, it was a digital playground for me to play in, where I can log onto a computer and make friends halfway across the world and talk to people in other countries without having to travel there, all from the safety of my own home. And while this was really fascinating, I was really intrigued with the idea of living in the real world. Like a lot of people really love playing in the digital world and staying in there. I had really wanted to still be part of the physical world and do things with my hands and have human friends that were near me. And so robots were kind of like the perfect solution, where it bridged the digital world with the physical world and kind of brought whatever you programmed to life. And while I was little, I really enjoyed, I learned HTML, started programming or learned the basics of logic at a young age. So in grad school at Johns Hopkins, where I went in Baltimore, Maryland, I also started working on in the world of combining the surgical world with the engineering world. So working on the world of surgical robotics. And as you can see, I really like the intersection of different types of things, where you really get out of your comfort zone and you learn something that you're a total novice in. So I had an engineering background for my undergrad and had worked in different types of robotics, such as you guys saw pictures of underwater, space. But what really intrigued me, what seemed like a really hard thing to me, was the surgical world. And when I was young, I had wanted to become a doctor and thought that that was the best way to help people. And then someone had pulled me aside, one of my teachers, and had told me about how technology can actually impact more people. And I had volunteered as a candy striper for 4 years at the local hospital and had seen how busy the doctors had been and the nurses, and was really trying to figure out a way to help people. And I had this insight that maybe through engineering and technology and building something that millions of people can use, you can help impact a lot more people. And it was like the idea of the pacemaker that really surprised me and that sent me on this path to work in clinical and engineering. So So I got a chance and I was lucky and fortunate at Johns Hopkins to take a surgery for engineers class, and we were really working on these robots that can be used to help surgeons become superhuman. Traditionally, when you think about surgery, it might be pretty graphic in the sense that if you want to perform like heart surgery, you might need to break open the sternum and to access the heart, and that's really invasive. There's huge blood loss, large scarring, and a huge recovery time. And in the year 2000, the picture on the your guys' right there is the Davinci robot, and I'm going to show you a quick video and then talk about it. Let's see. So there's a little bit of noise here. So how many of you guys remember the game Operation? And so this is to showcase the skills of, as a doctor, trying to gain the strong skill set of how do you perform with extra precision. And you start to realize the limitations of a human. We have very shaky hands, and it could be extremely frustrating. So if you were to apply technology to this problem, one way to do it could be to build a robot. And like I said, a robot has, So this is the Davinci System. It is a commercially available system made by Intuitive Surgical out here in Sunnyvale. It's a teleoperated system, so the surgeon would sit on one end of the room, and it's separated by a 30-foot tether, and the patient and the robotic arms are on the other side. Some of the benefits to this is that you have 3D vision. You operate through these small ports, so instead of that large chest cavity getting opened, and now you have just small 5 to 8 millimeter incision. So after surgery, you would have less scarring and almost no blood loss, and you'd be up and walking in a couple of weeks as opposed to a couple of months. This robot also has hand tremor reduction. So, I mean, as a human, if you stick out your hand, you'll see how shaky it is. This has a filter that will get rid of this, the shakiness to have smooth motions with extra accuracy. And you can also have magnified views to make any difficult task a little bit simpler so that the surgeon can concentrate on the other decision-making skills that he would need. And so, there you go. And so we had, as grad students, we had submitted this film to the Robot Film Festival back in 2011 and won the People's Choice Award. So you can see that engineering can be really fun late at night in the lab. Just to share with you some thoughts that I have about the future of surgery, Rick Satava, who's a famous surgeon, has said that the future of surgery is no longer about blood and guts, but bits and bytes. So I think in every application that we touch, technology can transform and can transform a field. So I think they realized that in healthcare, you can combine technology to make a large impact. You had seen open surgery, minimally invasive surgery came around, you just saw robotic surgery, and the future I see is where you no longer need to make any sort of incision. You can go through natural orifices like your mouth and perform the surgery so that the patient might have a even faster recovery time. You can also, we're starting to see smaller and smaller robots. This is a pill cam robot, which has a camera inside where you would swallow it and be able to see the polyps inside a human's intestine. And machines are also getting smarter and smarter. Really, robots are just machines. And some ways that we can assist the human would be through smart instruments, so adding additional sensors that a human doesn't have, such as extra eyes, or be able to see night vision here. So this is the Intuitive Surgical Firefly. You inject a dye and it lights up when you, it lights up like a blood vessel so that you can see things and where the tumor is. And that's something that a human typically can't see because everything looks just basically red. And you can also do augmented reality. Outside of the operating room, you can also have intelligent robotic assistants. So we're starting to see robots as companions. And they can be like that cute little Pero robot. They can also tell you reminders of when to take your pills or vitamins and help you along doing like aerobic exercises. We also see telepresence doctors. So maybe a doctor, if you want to stay in the safety of your home, maybe a doctor can just wheel in there and reach a lot more patients faster without having to to be physically there. One idea that really fascinates me when we talk about teleoperation is this idea of how far can you perform a surgery and what the latency is. And latency really means the delay in time. The further the distance that it is, the more lag time there's going to be. So back in 2001, the first transatlantic surgery was done where the patient was in Paris and the surgeon was in New York. And they successfully performed a gallbladder surgery. And this was really fascinating to me, and this is one of the reasons why I got into robotics. The robot you saw in the video costs about $2 million with all the bells and whistles. And it's been sold in thousands of hospitals worldwide and been approved for a lot of different procedures. And I love working on robotics, and I want to make it accessible to everyone. Unfortunately, $2 million is too high of a price point. And it really got me thinking about how do I impact humanity at scale with technology that doesn't cost that much. So I started really getting involved in the maker movement while I was in grad school a few years ago, and I had published kind of 2 tutorials. One is the hack to the game Guitar Hero. So this had started with my friend Robert Armiger, who works on the DARPA next generation of prosthetic arms. And it's a really tedious thing to train. And so we talked about how do you gamify this training, and could it be accessible to everyone, not just the disabled. So we wrote up a hack and shared it with everyone where you can play Guitar Hero just by putting your 2 fingers together, and we've mapped that onto the different buttons on guitar. The second project is on low-cost, do-it-yourself blood pressure monitor that you can make for under $50. So one of the problems is that high blood pressure is one of the first indicators if your health is going bad. And in third world countries, hypertension for pregnancy is a large indicator, but they can't afford blood pressure monitor systems, or they don't have trained personnel to teach them how to use it. So we wrote a tutorial where it can automatically turn green if you're okay, or red if you're not, just to make it easy. So you can start to think, my headspace started moving towards how do you get the most people to use technology, and how do you impact humanity at a lower cost. At the same time, I started organizing a robotics competition for young kids. So I was really interested in tomorrow's youth, and how do you, besides just teaching adults, how do you make things? How do you teach kids to get interested in technology at a younger age? So put together the Hopkins Robo Challenge, which is currently in its 7th year and has had about 1,000 people join over those 7 years. And I really wanted kind of the first medical-based robotics program. So the challenge is, how do you find a tumor inside of a patient? So we use Lego Mindstorms, and they had to create a robot to detect that. So we had a grape embedded inside Jell-O, and we had them build Lego Mindstorms to find where that tumor was and inject a needle in there and a dye to make sure that they got that right. And it was an interesting one because so often we don't think about soft tissue. So a lot of robotics is all based on rigid, hard things. And the human body is soft, and people are soft. And if you're starting to design for robots that interact with people, you have to start thinking about design in a different way. And so I started having, as you can see, I have a lot of fun with engineering. While we work on big problems, I think it's really important that you experiment and stay young, and you stay very curious about a lot of different things. So this really intrigued my interest in working with children, because it was exciting to see all these high schoolers learn about engineering. And it was something that I didn't have. My first real programming class was in college, as freshman year. And it was a really uneven playing field, because I had entered into my first freshman class, and it was really intimidating because I was surrounded by all these guys who had been programming since they were 8, and I really wanted the next generation to start at a younger age. So one thing I really believe is that coding is the literacy of the 21st century. So if you learn to read and talk, and when you're in college, you're going to be at a huge disadvantage from people who started a lot younger. So I believe that we have to start learning how to engineer and code at a much younger age. So I started talking to kids, and I talked to hundreds of kids, and one of the things that I learned from them is that about robots and engineering was that, one, that robots still have, since I was little, had a really bad perception problem. The media portrays this narration of robots being evil, robot overlords taking over, and I think that it instills a fear in kids, and they don't want to design for something that's going to take their job, and I don't think that's healthy. I think we need to have more the Japanese culture has a very open, creative relationship that's fun with technology. The second thing was that they believed you had to be a super genius. The third was that they didn't know how to even start programming a robot. It was when I asked them that we could work and build on a robot today, they couldn't list out the steps. It was basically step 1, buy parts, step 2, finish your robot. And so I really wanted to break down that design process. And the last thing really bothered me, which is where a lot of people thought it was a guy's thing. And they thought it was very masculine. And so one of the questions is, where are all the girls in engineering? So this was currently girls make up 14% of the engineering workforce, and that number is declining. And we believe it's a lot lower if you look at just real, if you define what an engineer is. So it's basically 1 out of 10 are female. And a couple of reasons I attribute to this might be this idea of perfection. So I think maybe girls more than boys strive for not failing, and they're not used to not getting perfect. So girls lose interest in math and science at age 8, but have also been shown to score higher in math and science all the way through high school. So it's not an intelligence thing, it's a confidence thing. The second is this mindset idea where they're not used to being risk takers and putting themselves out for failure. And engineering is all about failing because you're trying to solve a problem. So if it worked perfectly the first time, that doesn't make any sense and you'd be out of a job. The third is the lack of role models. And so one of my role models is Ada Lovelace, who's actually the first computer scientist ever in the 1800s. Her name is Lady Ada, and her father was a famous poet. And she really liked this intersection between writing and computer science. And she believed that your brain could do both. And she believed, before even calculators were invented, that there might be a day where we have smart machines. And we're still not there. And so it was really encouraging to see a female role model. And so this was one of my solutions after talking to so many kids, is this world of Ada Beta. And it's a girl who's just very normal, and you get to go along with her to design a robot. So these are 3 interactive books where kids learn about different types of sensors and different materials. And I started realizing that there were all these stories in the world of robotics that were not intimidating, taking over robots. But if you had robots and humans that work together to solve problems, or if your robot is sick, how does a human take care of a robot, and how does a robot effectively take care of a human, and the differences? So thinking about the space of robotics has really taught me what it means to be human, and how we can maybe even design ourselves better. We each have complementary strengths and weaknesses, and how do we work together? And also, most people, it was really cute, one of the kids I had asked, he didn't believe that robots were a real thing. He thought that it was a fake thing from movies. And so he was very impressed that I had worked and designed robots for a living. So I think it's just, as we're moving towards hard robots that are in factories that are dangerous, kind of what needs to happen for them to start coming into our homes and interacting with people. And that's kind of what I've been thinking about. So we need different types of materials. Robots need to be probably soft and interactive. There's a lot of different new research coming out about soft robotics. We have conductive thread and new types of sensors. One of my favorites, and one of the ones that the book is based off of, is a color sensor. So you can hold up the sensor to any color, and it will change and match it. So if you hold it up to an apple, it'll turn red. I think that's pretty cool. So I think that coding is not, and making and robotics is not for the elite. Anyone can do it. I think that it's great to start early, but you can start really at any age. And the advice to kids is to prepare for jobs that don't currently exist. But if I was in high school, I didn't know that the field of surgery and surgical robotics even existed, and I could have never prepared for it. I think what we need to do is to have kids really prepare for any sort of skill set. Technology is moving too fast that you can't know what you want to be when you're in high school, and so when people ask you that, it's fine if you don't know. I think what we do need is for kids to have to take risks and to really experiment and to really be empowered by technology. So I hope that I've shared with you how my vision of the future in the world of robotics looks, and I hope that whatever future that you guys imagine, that you're able to build it yourselves. Thank you.
Thank you, Carol. Are there any questions? If people have questions, come to the standing mic in the center.
Yeah, do you guys have any questions? Great.
Yeah, hi.
Hi.
I'm just wondering what, is there a possibility that robots can help us with solving climate stability, reducing CO2 in the atmosphere and oceans?
Yeah, I definitely think that it can. I think a lot of people are really working on that area of research because we're coming into a lot of different problems as the resources on Earth are getting limited. I think agriculture is a big one. My friends over at Blue River Technology has built a robot to help with farming and irrigation and reducing waste. So I definitely think that robots can do certain things better than humans, and that's definitely an area a lot of environmental engineers are working on. So
how do you keep requirements like risk management and design controls from bogging down innovation?
Yeah, so that's a great question. And so I think when I was in research and innovation are kind of on the flip side of product, kind of like when you do your design lockdown and you go into production, they're kind of the opposite of research. So research and manufacturing are kind of on the opposite ends, because once you've locked down your design, you just want to produce as many as possible. And I think a lot of times you get stuck in the paperwork of it and trying to get a product that's safe to people. I think brainstorming and design is a lot of fun, and I think they're two separate things, really. I think it's hard to be innovative when you're trying to get a product out. And for a long time, I've stayed in the research R&D side of things and have not really worked for years on full product. So, yeah, thank you.
I have a question. In this issue of confidence building,
Yes.
Is it a process or is it a moment of truth kind of thing?
Yeah, I think probably the first step is just the awareness of the problem. One of the things I've realized working in engineering is kind of calibrating for when I work with some of my guy friends. Like a lot of guys, and I hate to really separate it out, and I really had tried to avoid it when I was working on my book, but it was such a big problem in today's world. Just calibrating for the swagger, I guess. Like a lot of my guy friends, even though they knew less than me, would still be like, "Oh, I got this. I could do this." And for me, I've been always really upfront. I think one of the stats that stuck out in my mind is when people negotiate their first job, 57% of guys will ask for a raise, but only 7% of women. So I think guys are trained more to reach, and women only apply for jobs that they're highly, highly qualified for and might be overqualified for. So I'd encourage them to take higher risks and try that at a younger age, because I think if you're used to just throwing yourself out there and getting rejected and realize that it's not that bad, then you'll just keep on stretching. So I think just really this idea of reaching beyond what you're currently comfortable with. Yeah.
Yes, I have a question.
Yeah.
I heard, is there like a platform in which children or their family can make their design of a robot or something and submit it online, and then a company approve it and then produce them on the mass market?
Right. So there's a couple different platforms, none specific for kids, but Arduino, for instance, is a really popular platform to build something. Kickstarter is very popular to get your initial funding and run, and to test your customer market. and you can do like Alibaba or something to manufacture in China. And that was kind of like the process I went through to do my book design and what I'm doing through my toy design. So that's just one possible route, and I think we're really lucky today that everything is so open, and there's a lot of different paths to get a product out. And
if a children in the family is able to design something and then submit it and it being mass-produced, it will be a good encouragement for them to continue the route. So that's why I want to ask this question.
Yeah, and I don't think it differentiates between adults and kids. There's nothing kid-specific, but for like that same path that I talked about is something that kids should do and learn how to run a business. I think it's not. I think engineers and anyone should be able to learn also the business skills to do it, and also vice versa. Even if you're interested in running a business, if you're gonna learn everything. Like my advice is really to pick up everything. If you're gonna learn a different language, like learn C++, you know, like instead of Spanish. Like you should just, even if you're never gonna use it, I think it helps inform how your brain develops. Yes.
Last question.
One last question.
I want to learn how to build a robot. Where should I start?
Yeah, that's a great question. So one of the things I could ask you that question. So I think when I get kids to do robots, one is the brainstorm. How do you want to design it? So I think you need to fail as quickly as possible. So sketch as many different ideas as possible. Talk to people about your design, and everyone's willing to help. The next step is, once you've got a really cool design, is to buy the parts. And then I think one of the things is, with the robot, you have to find a problem. So you don't want to build a robot just for fun. Engineering, you need to find a problem that you care about and that you think other people care about. And so design for that solution. For instance, if a robot was to interact with the world, what type of sensors do you need? Like if you want your robot to see, what would be one part that you would buy? Like any suggestions? Like anyone, I guess, in the audience, if you wanted your robot to see, what would you need? What would be one type of sensor you can get? Yeah, you can. Right, so you could get a photodiode, you could get a camera, you know, and then you would make a decision. Would you want to buy one camera or 2 cameras or 5 cameras? So this is an interesting thing. If you cover up your eye and just walk around with your one eye, well, I guess here's a question. So why do humans have 2 eyes? Like, what is the purpose of 2 eyes? So if you cover up your one eye and walk around, you'll realize that you lack depth perception. So you're going to be running into anything. You're able to really see in the 2D, and it's really hard to do things. And so one exercise we have people do is to cover up one eye and turn around to the person next to you and stick out your pinky and try to have the 2 pinkies touch, and you'll realize that it's a difficult task and how easy it is with 2 eyes. So something like that is an example of how humans are designed. But if you want to so you could do that with a robot. You would add 2 eyes and have them see depth. So what value would 3 eyes be, or 4 eyes? So things like that might help you understand how to design a robot. And I'd be happy to talk offline. And I've been in this book with Ada Beta. The website is Squishy Bots, is just kind of thinking through this process and what all these things are and why they matter. So it's not just the cool factor of building a robot, but really how do you design a solution for a problem.
Thank you, Carol.
Thank you.
Will you be able to talk outside for a little bit?
Yes, I will do that. So I'll be outside. Feel free to email me or anything with any questions or suggestions. Thank you.